Okay, so we are going to solve a pattern exercise using a quadratic sequence, which you can see right now here on the screen. Okay, so you will notice that it's a quadratic sequence. Well, at least you will notice that it's not a linear pattern, a linear sequence, because the difference is not constant. Here, the difference between 12 and 20 is 8. Here is 10. So, yeah, right from the start, we know that it's not linear. Okay, so mm, this is a quadratic one, and in order to find the general rule, you will follow a structure like this one. Okay, you will have y equals a times x squared plus b times x plus c. Okay, x in this case is the variable of the position. Remember that could change according to each problem. And y is the number of the pattern in each step. Okay, so we will need to find what's a, what's b, and what's c. And we are going to begin by finding a. So in order to find A, B, and C, we need to extend the chart, okay? Because we need um, to find the first difference and the second difference of this pattern, okay? So first of all, we are going to find the difference between 20 and 12, which we already stated, it's 8. Between 30 and 20, it's 10. Between 42 and 30 is 12. And we know, or we can assume right now, that it's growing. The first difference is growing by 2. You can see it. Look, the difference between 10 and 8 is 2. That's the second difference. Between 12 and 10 is 2. And you see that we start getting the same second difference always. So this is going to always be 2 if it is a linear, sorry, if it is a quadratic pattern. Okay, so if we know that the second difference is always constant, it's always the same, we can find the new differences, like the first difference here. So the difference between this one and the next one is going to be 2. So this one is 14. This one is going to be 16. And this one is going to be 18. And now we can complete the original chart of the pattern. We can find positions 5 and positions 6. Um, so from 42 to the next number, there is a difference of 14. So the number in that case is going to be 56, because 42 plus 14 is 56. And between 56 and the sixth position, the difference is going to be 16. So in position 6, there's going to be 72. And this 18 is the difference between position 6 and the next one, but since the chart, the table finishes here, we are not going to do anymore. Okay, so with this chart, we can identify or start identifying the numbers that we want. We will know what is A, then what's B, and then what's C. Okay, so take into account how to fill this chart. Always remember that for quadratic patterns, you have a first difference and a second difference, which is always constant. If the second difference is not the same always, that means it's not a quadratic pattern. Okay, so let's move to the next slide where I already have this chart typed. So yeah, it's the same one. Now we are going to start using it in order to find um, the coefficients, which is the term for these numbers, of the general rule. Okay, so in order to find A, we have to use this um, formula or this fact. A is always going to be the second difference divided by 2. So what is our second difference in this case? Our second difference is always 2. So it's going to be 2 divided by 2. So 2 divided by 2 is 1. A in this case is 1. Okay? So we already have A. We know that there's a number 1 here. Okay, but we still need B and we still need C. So remember, A is 1. Now, in order to find B, we need to find this formula. Okay, 3A plus B is the first difference. So we can rewrite it, and we know that B is going to be the first difference minus 3 times A, or 3A. Okay, but when we're talking about the first difference, look, you have first difference, this row, but you have 8, 10, 12, 14, 16, 18, so which one of these? And it's always going to be the first one. We have it indicated here with this green box. So in this case, it's going to be the 8. So let's do it. Let's actually do it. Okay, B is going to be our first difference, 8 minus 3A. So what is A? Remember, we found in the previous step that A is 1. So 3 times 1. Okay, 8 minus 3 times 1 is just 8 minus 3. Yeah, 3 times 1. And that's 5. Okay, so B is 5. Time to go to the next step. Now remember, we already know that A is 1 and that B is 5. Okay, so here I didn't complete the chart, but anyway, we know that this is 8, 10, 12, 14, 16, 18, and all of this is 2. Okay, in order to find C, we use the formula A plus B plus C is the first term. Okay, what are we talking about when we say first term? The first result for position 1. Yeah, we indicated for this box with this red box. So this one is the first term. So again, we can rewrite this formula to say that C is the first term, which is 8, minus A, which is 1, minus B, which is 5. Okay, so 8 minus 1 8 minus 1 minus 5 is 6. Okay, so C is 6. Okay, so remember, we have to follow this structure, and we already know what are A, B, and C. So let's follow it. Y equals A, which is 1 times x squared, plus B, which is 5 times x, plus C, which is 6. Okay, so let's write it in the simpler form. Okay, because here if you multiply by 1, it's just the number, so you don't need to actually write this 1, so it's just x squared in this case, plus 5 times x, just 5x, plus 6. This is our general rule. Okay, this is going to be for this pattern, sorry, this one. Okay, the one in the green box. That's the general rule. Okay? Remember, always write it in the simpler form. So now it's time to test and verify and justify. So let me write again the general rule. Y equals x squared plus 5x plus 6. That's the general rule. And in order to test, we have used one of the values that we were given in the initial table. So we can use either 1, 2, 3, or 4. We can't use to test the positions 5 and 6 because they were not given. Those are used to verify in the next step. So let's select any of these. I am going to pick position 3. So we are going to test for position 3. So x is going to be 3. So let's take the general rule and replace the x for 3. Okay, so y is x squared, so that would be 3 squared. Okay, plus 5x, so 5 times x, which is 5 times 3, plus 6. Let's do it. Y is 3 squared, which is 9, plus 5 times 3, which is 15, plus 6. So y is going to be 30. So yeah, for position 3 we got 30, so the general rule works. Okay, always state that it works, or that it was tested successfully, or that you got the same result in the table. Always state it. Don't just put this. This is important, but this is also important. So now, for verifying, we are going to do exactly the same, but with positions 5 or 6. Remember, don't go outside the table. Just 5 or 6, which we know to be 56 or 72. We are going to check if that's actually correct. So let me write it again. 56 or and 72. We are going to check if what we wrote at the beginning is correct. So again, general rule was y equals to x squared plus 5x plus 6. So let's pick positions 5 or 6. I am going to do it with position 5. So I am going to verify for x equal 5. Okay, so y should be x squared, so that would be 5 squared plus 5 times x, so 5 times 5 plus 6, so that is 5 squared is 25, 5 times 5 is also 25 plus 6, and 25 plus 25 is 50, and plus 6 is 56. So yeah, it was verified successfully. Successfully. Okay, that's it. Now, for the part of justifying. Okay, this is a quite straightforward process. I know some of you may be confused by this, so just bear with me and follow me. If you already completed the chart, which like this is the same that we have done, we are just going to add 2 more columns, because we are going to find a times x squared and y minus this, okay, the previous done what that we are going to find. Let's do it, and actually then I'll tell you how to justify. Okay, so excuse me. Fine. So, oh, excuse me. I also moved this. No problem. Okay, so ax squared. So what was a? Remember, a was equal to 1. So 1 times 1 square, that will be 1. Okay? Now 1 times 2 squared, 1 times 3 squared, 1 times 4 square, 1 times 5 square, 1 times 6 square. Okay, let's do it. So what is 1 times 2 square? So that's 4. Okay. What is 1 times 3 square? That's 9. This one is 16. This one is 25. And this one is 36. Okay, so let me erase the operations. So we just stay with the values. Okay, then what we are going to do is making y minus the previous values that we found. So look, let's do it. What is 12 minus 1? 11. 20 minus 4? 16. 30 minus 9? 21. 42 minus 16, that is 27. Sorry, 26. What is 56 minus 25? That would be 31. And 72 minus 36, that will be 36. Okay? So why did we do this? Okay? Because when we do that, if we have done it correctly, this would be a linear pattern. All of this row, okay? All of these, sorry, it's difficult. All of these is going to be a linear pattern. And remember, a linear pattern has a constant difference, a common difference. So between these two, there's 5. Between these two, plus 5. Yeah. We add 5. Here we add 5. We add 5. Yeah, this is a linear pattern. So the next step that we are going to do is to find the general rule for this pattern. Okay? So y minus ax squared is going to be, okay, remember, a linear pattern, okay, a linear pattern has a general rule like this. Okay, let me see. Excuse me, y is the common difference multiplied by the position plus or minus the complement. Okay, so here, what is the common difference? The common difference was 5, so 5 times x in this case. Okay, and the complement, you get it by taking the first term of that linear pattern and subtracting the difference. So it's 11 minus 5, which is 6. Okay, positive 6. So this is the general rule for this new thing. Okay, so once we created this general rule, then if you got B and C, that means that you justified the general rule, like the quadratic one, successfully, because you got the same values from another algebraic method. Okay, so then test and verify this new general rule. Okay, I'm not going to do it because you know how to. and after that you can say that it was justified successfully. Okay, because look, what was B and what was C? 5 and 6, right? Yes. So we found them by other method. So what happens if initially you do this in order to find B and C? Because I know some of you learned the opposite way and find B and C starting like with this method. Okay, so if you do this at the beginning, then you can justify by doing all of these, what we have done. Finding A this way, and you will find the same one. Finding B this way, and you will find the same one, and also for C. Yeah, you basically can switch your justification with the way that you find the general rule. Okay, so if you do it like I did, then you justify like this. But if you find the general rule like this, then you justify by doing all of this. Yeah, that this is test. So that's it, guys. I hope this is helpful. See you in a different occasion. Okay.